Mr. Remus will be here tomorrow. Now, what I want to start the period with, hush. And the rest of the period is getting those problems with us. Hush. All right. One of the classical problems is dealing with motion. So suppose that you're on the ground and you shoot an object vertically upward from the ground. And suppose that the function rule is this, which it very well may be. The rules look like that. What happens to the object? It starts out with an initial velocity of what? It says. No, if it was zero, it wouldn't move at all. Okay, so it's shot upward, hurled upward, thrown upward to the velocity of 96 feet per second. Now, as it moves upward, does it speed up or slow down? It slows down due to the influence of gravity. That's this minus 16 squared. Eventually, it rises to its highest and then begins a downward descent, right? Eventually hitting the ground again, right? Coming to Earth. Now we need to look at this just a little bit. Again, humor me, this is very important because we don't have any periods to waste or no way. How high is the object after the beginning? Say zero. Yeah, you're right. It isn't left there, okay? It's here. After 1 second, how high is it? The unit of height is feet. 80 feet, right? After 2 seconds, how high is it? 192 minus 64. Put in, to help me out, put in T's too. Do I have it confirmed? Marcus says 32. All right, let's do the following. Let's make our lives easier just for practice. In your calculator, put y1 equal to 96x. Why should we do this as slave labor? Minus 16. Okay, so let's let the calculator do the work. All right, practice. Put in y1 equal 96x minus 16x squared. And then in the top row, you have something called table set. You see that button, table set, at the very top? Table start or something like that is equal to 0. Delta table. Let's go our time increasing by second at a time. Good luck with that.
Oh, I have it. Oh.
Put in y1 is 96t minus 96x minus 16x squared. And now press table set. Alright, table start is 0 seconds, and we're going up by 1 second at a time, right? Then press table, which is second graph up at the top. And you see in the left-hand column the time should be 0, 1, 2, 3, 4, 5, right? And to the right you have the height. It's all worked out for you. So after 2 seconds, how high are you?
120.
After 3 seconds?
144.
After 4?
128.
Same as after 2, right?
Yeah.
After 5?
80.
Same as after 1. What about after 6?
0.
And that doesn't surprise you because you're mathematically smart, and I don't mean that as an insult, I mean it as a compliment. You know that when you see this equation, and its highest power is 2, then you know its graph must be a, and you know because there's a minus 16 in front of the t squared instead of a plus 16, that she's not concave up, but concave down. Okay? So the object rises to its highest point at 3 seconds and falls to its lowest point 6 seconds. The entire episode takes 6 seconds. 3 seconds up, 3 seconds down. All right, now check this out here, students. At every stage along the way, you've got a tangent line. At the origin, or when this whole procedure starts, there's a tangent. Horizontal, it's a tangent. What's the slope here, positive or negative? It's a positive velocity, 96 feet per second. A derivative is a rate of change. Mr. Remus is going to preach this till he's blue in the face. So the slope here turns out to be 96. All right, this is the velocity when you start, the rate of change. Feet. Oh, I got over there. Feet per second. It should be over there, not over there. I think you grabbed this. All right. Be that as it may, you get over here, the slope is positive, but what, more or less? Is it going up more steeply or less steeply? That corresponds to the fact that as you go up here, the velocity is less. Eventually, at 3 seconds, the tangent line is horizontal. What's the velocity there? 0. There's a momentary pause up here before the descent begins. And then, to the right, the slope is, that means you're going down at it with a negative velocity. Okay? And it turns out that the velocity at, let's say, 2 is the same as the velocity at 4. As are their distances because of the nice symmetry of the parabola. What about at 6? You win the prize if you can tell me how fast it strikes the ground. Assigned you, you win. It rose here with a velocity of 96 feet per second. That was the rate of change. The slope, that's the velocity, 96. Because of symmetry, it has to hit the ground with a velocity of 96 feet per second. This is plus 96. This is minus 96. The distance is 0 in both cases from the ground. It's on the ground. It's at the ground. If you understood this and nothing else this period, you got something very big in